Welcome to this screencast to look at the components of a CPU question in WJEC Specimen paper from 2014 for their GCSE. My name is Mr. Gauvin and this is a screencast for my GCSE students. If we have a look at this question too, we've got a drawing of a CPU with arithmetic and logical unit, the controller and the internal memory, followed by a question for each one of these asking us to describe their purpose. Well, you all know the ALU, you know this is what is actually performing the operation. You all know that inside the CPU there's a little bit of memory, and the one component that you may not be as familiar with is the controller, which is the first one you're asked to describe. So you may want to skip straight to the ALU. Now, in your when I use this question as in preparation for your GCSE, quite a few of you forgot to mention the logic part of the ALU. You all explain that it does the maths, but you forgot to write about the logic. If we let's write down here an answer. So I've actually prepared this earlier. Let me just copy and paste it. That will be faster. So the ALU, and you have a clue in the wording of a question, they are very kindly tell you arithmetic and logic unit, does the math and the logic operation. And then you can even give an example. You can add, multiply, and so on, and also do logic operation. And there are some logic operations that you know, the and the or, so you can give them as examples. So that's our answer for the ALU. If we scroll down a little bit, there's the question about internal memory. If we do the same thing here, so the memory over here, where the instructions are queued. Well, you know they are queued because you know that a computer program is a series of steps, one instruction after another. So the internal memory is there to speed things up, and you're going to fetch the instructions in advance from the hard drive or even from the RAM to store them directly inside the CPU. So you're going to have your queue of instructions for the CPU to follow. And then you don't just have instructions, you also have your data. So what goes inside the CPU and then what comes out of the CPU is going to be stored, temporarily of course, inside this special area of memory within the CPU. So I wrote there before and after being processed by the CPU. Now we've gone the first two that we all know about. Well, what's left for the controller to do? Again, there is a clue, inside its own name. Controller is here to control, but what is it that it has to control? We've actually written it already in the other two answers. You've got to control the data that goes in and out of the CPU, and you also have to control the instruction. And there's one keyword here, manages the flow, because you constantly have loads of data going inside your inside the CPU, inside the internal memory, and then once it is in the CPU, it's going to go from the memory into VLU when instructed to do so by the controller. VLU is going to perform some operation, and then the result is going to be stored inside the internal memory to be reused later by VLU, or if it's a final result before being sent back to the RAM and then maybe later onto the hard drive. So we've got our three answers: controller, ALU and internal memory, which then leads us nicely to the question about the fetch, decode, execute cycle. What does that do? Then again, you have a clue here in the wording of the question, in fact in the name of this cycle, fetch, decode. So what we've got to fetch are the instructions. So what this does, it's in the description that you fetch an instruction from the memory into the control unit. Next, that instruction needs to be translated into machine code. Now, you can say translated, or quite often it's a fetch, decode, execute cycle. So let's use the same decode keyword into machine code that the CPU can understand. The last step is for the CPU to execute, to do. Now, if we link this back to what we explained before, the architecture of a CPU, then the fetching into the control unit, I've said it here, and the instruction is decoded. This happens inside the control unit as well. So let's see if we can rephrase it to put that in there. It's into machine code by the control unit. Last step is for the CPU, so to execute the instruction. So that phase of instruction could be performed by the ALU if it is an operation or calculation, or if it is to fetch some data from the memory, then that could be done by the internal memory, which in that case that would be the registers, or to write some result from that the CPU has calculated and to save it in memory. So that would be an instruction as well, but this time this would be not done by the ALU but by another component inside the CPU. So there's a perfectly good answer to that question, and I hope that these explanations have helped you to understand a bit better about the CPU. Now, these questions did not come up in the 2014 and 2015 exam, but they were into the specimen paper that WJEC released when they created this GCSE. Best of luck for your exam and keep on revising.